Light paths control Cycle's global illumination characteristics, and to demonstrate these settings, I'm going to be rendering comparisons with 100 samples and no clamping. So currently I have the default light path set up, and let's render this so we have a place to start from. All right, this doesn't look too bad aside from the extreme noise in certain spots. But as far as the glass, it looks realistically transparent, and the bounce lighting looks pretty good. We have a little bit of green spill from our orb object onto the floor, and our shadows are nicely illuminated from the world that we have emitting light that's also bouncing off of these objects. And so to explain what these settings are doing, let's switch to slot number 2 and use the presets available to us. Even though this shows that full global illumination is selected, these aren't the actual full global illumination settings. So we're going to come back to this. First, I want to start with the direct light preset. And what you'll notice with direct light is all of our settings went down in value a little bit, especially with this bottom right section, diffuse, glossy, and transmission. These are the ones I want to focus on. The maximum and minimum and transparency we'll come back to later. Also, our caustics have been disabled entirely. So let's see what this direct light preset gives us. Really, this isn't that bad, at least in terms of realism, when you compare it to, say, Blender Internal. We still have the environment lighting illuminating our shadows so they're not pure black. We see reflection both from our lamp object and the world, so those are believable enough. But we don't have any spill from this green color. If I hit Alt-J to go back, notice that there's a hint of green on the floor. With the direct light preset, there is no bounce lighting, no color spill. But that's a fairly subtle change, and this still looks believable enough in my opinion, especially with the render time of 26 seconds compared to 36 from before. That's a significant time savings. However, the biggest offense in this image is by far this glass. So over here, the transmission bounces. That's what's controlling how far our light can pass through the object. So I'm going to switch to slot number 3, exit out of this, and select that cup. Hit the / key to go into local view, 5 for orthographic, and 1 to look from the front. And then finally Z to go into wireframe so I can illustrate what I mean by a light ray and how it travels through the scene. So being a transparent material, let's say we have a light ray coming from the left side of our screen. It hits the object once, and that is 1 bounce. And so since we have the transmission setting to 2, the light is able to travel 1 more bounce till it hits another surface, the inside of the cup. That is number 2. And then based on the settings, we've told it to terminate. However, realistically, light would be able to travel a 3rd bounce, a 4th bounce, and then a 5th bounce onto what's ever on the other side. And so since we have terminated the transmissive bounces at 2, that is what's causing the black on the inside of the cup. And so back into slot 3, let's take our transmission up to 5. There we go. Now we can see all the way through the cup, and we're a little bit closer to realistic, even though 5 bounces is far less than reality, which is infinite bounces. But even for Cycle's capability, it can handle many more bounces that bring it closer to photorealism. But since the whole idea of manipulating these light paths is to optimize our render speed, remember before, if we go back to the default settings when our numbers were higher, we were at 36 seconds, so now we're at 27 seconds, a significant time savings, and we're closer to covering all the bases of realism, or at least the impression of realism. And so that's the benefit of keeping these light paths low, even as low as the direct light preset. Next, let's take a look at the glossy bounces. So direct light has set that to 1. Let's turn that to 0 and see what the difference is. Jumping up to slot 4, let's kick that off. 0 glossy bounces looks pretty bad, very unrealistic, and that's because we've told the reflections to participate in direct lighting only, but the objects don't even reflect each other. Especially right here, in this section of the orb, if we go back, you can see the reflection of this glass, but with 0 glossy bounces, it has disappeared. And so for minimum believability, as implied by the direct light preset, we need at least 1 glossy bounce. And the way you can think of glossy bounces is if you've ever been in like a house of mirrors or just a bathroom that has mirrors on both sides of your head, where when you look in it, you see kind of an infinite array of reflection because the mirrors are reflecting one another. And so in Blender and Cycles, you can do the same thing, but it will never be infinite in the computer. And so we can use the glossy bounces to determine how many times it will reflect before terminating the ray. Next, let's look at the diffuse bounces, which I've talked a little bit about. And that is where the light hits a surface like this and then just terminates. Whereas realistically, the light would come in with a certain amount of energy, then it would bounce off, hit the next surface, lose a little bit of energy, and then bounce again, repeating this process until all of its energy is depleted. And so this bouncing is where we get the light spill that we see in our original render, where this light ray has taken some of the color of the object and bounced it onto the surfaces around it. However, with a diffuse bounce setting of 0, we get none of that. So if we change this to 1 and jump to slot 5, let's go down 2 slots where we at least had 1 glossy reflection but 0 diffuse bounces. So that's slot 3, and now when I jump to slot 5, you can see that our shadows have brightened up because we get at least 1 bounce, and then it terminates right here. It doesn't continue on. But at least with 1 bounce, we've taken an important step towards better realism. And the render time difference here is from 30 seconds with 1 diffuse bounce to 27 seconds with 0 diffuse bounces. So as you can tell, the more bounces we add, the longer our render will take.